All right, in your previous lesson, we looked at translations for sinusoidal functions, and in this lesson, we're going to look at stretches, compressions, and reflections. And then after that, in your next lesson, we'll put all the different types of transformations together. So what you have at the beginning of your note here is sort of an explanation of the parameters in your equation that will tell you what the stretches, compressions, and or reflections are. Beginning with the a value. Okay, the a value is located right after the equal sign, like always, for lines, parabolas, you name it. And when it comes to sinusoidal functions, the a value is what tells you what the amplitude is. Okay, so that, of course, is the distance between the horizontal axis and the maximum, or the horizontal axis and the minimum. And when that a value is a fraction between 0 and 1, the function is compressed vertically, okay, by a factor of whatever that fraction is. If the a value is greater than 1, it is vertically stretched by that factor. And if a is negative, in addition to the stretch or compression, you also have a reflection in the x-axis. All right, then similarly, the k parameter is the one that deals with horizontal stretches and compressions and reflections. Okay, now the k value tells you the number of cycles that will occur in 360 degrees, which is the normal length of one cycle. So changing the k value changes the period length of your graph, which of course is equivalent to a stretch or compression, a horizontal stretch or compression of your graph. So this would be an important formula right here to make note of. Let me grab the pen. Right here, where it says the period of the graph is equal to 360 degrees divided by the absolute value of k, which basically just means if k is negative, we just use the positive number in the formula. Okay, and same at the beginning of your note here when it says the absolute value of a is the amplitude. That just means if a is negative, we don't consider the negative part, okay, as the amplitude. So if a was -3, the amplitude would be 3. And not to worry, we'll go through some specific examples here momentarily. All right. Right here, though, we have the description of the different possibilities for your k value and the impact that would have on the graph. So if k is between 0 and 1, the function is stretched horizontally by a factor of 1 over k. Now that is opposite to what we would think, okay? So in other words, if k is a fraction of, say, 1/2, that corresponds with a horizontal stretch, not a compression. Whereas with the a value, it's a compression. So it seems a little bit backwards here when dealing with the k value. When k is greater than 1, so say k is like 5, that is a horizontal compression. Okay, so again, seems backwards. And if k is negative, sort of like if a is negative, you're dealing with a reflection. In this case, it would be in the y-axis. Okay, so that's a lot of information to take in quickly. So let's go through some examples here, but you'll have those charts, of course, to refer to while you get used to these different parameters and what all these numbers mean. So in this example, we were asked to find the vertical stretch or compression, the horizontal stretch or compression, any reflections, the amplitude, and the period, okay, for each function. So what I would do for a question like this is break it down in terms of the a value and the k value separately. So in this first one, we can see that the a value is 4, okay, which tells us, according to your chart, that this is a vertical stretch by a factor of 4. So we've taken the original graph of y equals cos x and stretched it vertically by a factor of 4. The k value in this question is 3. And looking in the chart above, we can see that when k is greater than 1, we're dealing with a horizontal compression. And now you see what I mean about how this seems backwards. Okay, you would think that that would be a stretch, but when dealing with the k value, it's backwards. So this will be a horizontal compression by a factor of, and here's where we will not say by a factor of 3, we will say by a factor of 1/3. So if you look above in the chart for the k value, notice it says if k is greater than 0, right here, the function is compressed horizontally by a factor of 1 over k. Okay, so since k was 3 here, it's compressed horizontally by a factor of 1 over 3. There are no reflections happening here. The amplitude is the absolute value of the a value, which is 4. Okay, so a is positive, so we don't need to get rid of the negative here. And the period, remember that formula I showed you at the beginning, 360 degrees, divided by k, which in this case is 3, so the period of this graph is 120 degrees. Okay, let's try the next one. In part B, we have an a value of -2, which means we have a vertical stretch, once again, this time by a factor of 2, not -2, just 2. Okay, but the negative sign indicates that we also have a reflection in the x-axis. All right, our k value is 1/4, which tells us that we have a horizontal stretch oh dear, that is supposed to say horizontal stretch, by a factor of, now 1 divided by 1/4 is 4. Okay, so we have a horizontal stretch by a factor of 4. So basically, the factor is only a fraction if it's a compression, okay, not if it's a stretch. All right, amplitude. Okay, the amplitude will be the absolute value of the a value. Absolute value refers to the distance a number is from 0 on the number line. So -2 is 2 units below 0. So the absolute value of -2 is 2. Okay, so it basically just means we ignore the negative sign. And the period of this graph is 360 degrees. Let's try that again. 360 degrees divided by your k value, which is 1/4. Now, 360 degrees divided by 1/4 is the same as 360 degrees times 4/1. Remember, when you're dividing by a fraction, you multiply by the reciprocal. So 360 degrees times 4 is 1,440 degrees. So the length of the first cycle on this graph is 1,440. So this one's really stretched out horizontally. Okay, part C. In this example, we have an a value of 2/3, okay, which tells us we have a vertical compression, since this is between 0 and 1. Okay, a fraction between 0 and 1 corresponds with a vertical compression by a factor of 2/3. The k value is -4, which tells us we also have a horizontal compression by a factor of 1/4. So 1 over k, ignore the negative, okay, because again the negative has nothing to do with the fact that it's compression. The negative tells us that this is also a reflection, this time in the y-axis. Okay, so it's like a horizontal reflection. Now in this case, the amplitude is 2/3, and the period of this graph is 360 degrees divided by the absolute value of our k value, so divided by 4. So the period of this one is 90 degrees. All right, at this point we're going to start looking at graphing some transformed sine and cosine functions. Okay, this time dealing not with translations, but rather with stretches and compressions. And this is a little bit trickier than strictly translating the graph as we were before. Okay, so in order to perform the stretches and compressions and reflections to these graphs, I'm going to introduce you to a new method of graphing called the box method. Okay, and at this point I will have you switch over to part 2 of the video, and I'll show you what that's all about.